Good afternoon. Hope everybody had a good lunch. We're going to go ahead and get started here. You know, last June I was in Beijing with Oleg from Postgres Pro, one of the organizers of the conference, if you don't know. And he says to me, GD, will you submit some content to PGConf.Russia? I said, sure, I'll give a couple of talks and you let me know what you want. So I submitted 2 trainings and a talk. I didn't know he was going to have all 3 of them. So this is a long day. Not complaining, just a little bit of a surprise. Don't take this personally, but who was in the training that I gave before lunch? Whoa. Okay, cool. Thank you. All right, so you know who I am, so I'm not going to go through all that again. The one thing I will ask is that all of you get your United States visas and come to our conference. It's March 18th through 22nd in New York City. 5 days of pure Postgres fun. We're going to have the first 2 days are training, as well as specialty vendor summits. So we got an Amazon summit, we got a Google summit, and then we have a pivotal Greenplum summit. Any of you doing big data stuff will love the Greenplum stuff. It's, if you don't know, it's a open source fork of Postgres that can deal with things like petabyte level of data. And then Wednesday through Friday, we'll have over 100 breakout sessions, cocktail party. The cocktail party, we have games, and I don't mean like bar games, I mean like we have foosball, air hockey, Dance Dance Revolution, those types of things. It's a lot of fun. It's a really busy, long week. But we're the largest conference in the world for Postgres, and we're targeting 800 people. If just the people in this room showed up, plus the people we already know are coming, we'd hit 1,000. So please come if you feel, you know, the need or the desire to see New York. It's a great place to go. This training is practical Postgres replication. I don't do theory. I leave theory to engineers and people who spend more time in front of the monitor. I'm more about how can I help you use Postgres in production. I think my battery just died. Nope, there it is. All right, so I'm not going to go through the table of contents here. This particular training may not go the full 3 hours. It'll depend on various things. The training itself only has, we only discuss, the first part of the training, we only discuss binary replication. The second part of the training is logical replication. If we don't get to that, it's the exact same slides of the presentation I'm giving tomorrow. So if we don't get to logical replication, because we didn't finish the performance talk, in fact, I was surprised. That training is normally a solid 3 hours in and out, and we probably wouldn't have been done at 5. So if we don't get to it with this, that's okay. You guys can definitely come to the presentation tomorrow, and we can talk about logical replication as well. Per the other training, this training succeeds based on your participation. Please ask questions. That's what it's for. I want to help. I just want you guys to succeed. Oh, there you are. What was that? I'm sorry, I can't hear you. Barcode. Oh, yeah, the barcode, we will get it. They're not here yet, but we'll definitely get you a barcode to download it. Okay. Here. Well, that's about the 300th time you've taken my picture, so I got to make it a little interesting. He will have the barcode. They're already asking for the barcode for the curriculum. All right, so introduction. This training is designed to provide an attendee with practical curriculum for Postgres operations in regards to replication. We will discuss types of replication available, provisioning, custom configurations, and administration. Expectations. This is a comprehensive but introductory training. If we were to cover everything related to replication, this would easily be a 3-day training, not a 3-hour training. We are trying to get administration up and running with basic but reliable knowledge to enable, administrators up and running with basic but reliable knowledge to enable them to use binary replication. We will also attempt to address logical replication. However, if we are unable to reach logical replication, I'm giving the same logical replication content as a presentation tomorrow. Versions. The curriculum currently discusses version 10 of Postgres. Let's talk about types of replication. Is that too small? I heard yes, so let's see what I can do. Is that better? Okay. Postgres has 2 native types of replication. The first and most robust is binary replication. The second and relatively new, not even relatively, it is new, is logical replication. Each type has its pros and cons as well as different administration requirements in order to deploy it into production. We will also briefly discuss previous replication options. What is not covered? We will not be discussing the following technologies in any comprehensive form. Point-in-time recovery, because that's not replication. That's backup and restore. Slowney, because you got to be nuts if you're running Slowney. Has anybody here ever run Slowney? You know what I'm talking about. Don't get me wrong. For the time that it came out, Slowney was a good piece of software. But it suffered from over-engineering. And the best way I can describe it is a bunch of engineers got in a room. They were told to paint the wall black, and they asked which shade of black. Way too many features, way too extensible. You want to do that real quick? Okay. Hold on a second, folks. Okay. We will also not be talking about Picardo. And we will also not be discussing multi-master. Now, don't get me wrong. If you want to ask questions about multi-master or Picardo or something like that, I can speak to a high level of them, and I can also help point you in the right direction to get the solution you need. When I say we won't be discussing something, I mean I am not going to teach on it. So please feel free to ask if you have the question. But if you say to me, how do I install BDR, I'm going to say call second quadrant. But if you say to me, what are solutions for XYZ, happy to try and help you find what you need. Why no discussion on multi-master? Multi-master is a difficult problem, and there's currently no native multi-master replication options for Postgres. Further, by far, the number of people who think they need multi-master do not understand the problem they are trying to solve. The number one question, or I should say problem people think they're solving with multi-master is performance. I hear it all the time. I want more masters so I can go faster. Multi-master does not, will not, and will never increase performance. That's not what it's about. It's about reliability across region. PITR, it's an acronym for point-in-time recovery. The technology uses log shipping, the wall logs, to allow a replica or slave to be a cold, warm, or hot standby. If you are using the cold version, you are able to restore to a specific point in time or transaction. Very, very useful. Has nothing to do with replication itself unless you have to ship logs for your replication. It's more used for disaster recovery. In case you drop a table, modify a bunch of data accidentally, you can restore to a point in time to get that data back. Slowney was the first production-grade logical replication option for Postgres. It is open source, trigger-based, and exceedingly flexible. However, due to that flexibility, it is also complex to manage and suffers from certain performance issues. The most obvious one is that unlike binary replication, with Slowney, the larger the number of replicas that you have, the slower everything goes. Bucardo is similar to Sloaney, except that it's multi-master. It is a multi-master replication engine. It is open source. However, as it is trigger-based, it suffers from performance issues, and as it is multi-master, it can be difficult to administer. One of the biggest problems with multi-master is conflict resolution. How do you know which row from which master is the valid row? There are other technologies available as application-level replication, which can be implemented using software such as Jakarta, Continuant, and various other proxy software. ProtoDB is an example of that. All right, so let's talk about some initial replication questions. There are 3 questions that we must answer before we can determine the best kind of replication for your needs. Do I need synchronous or asynchronous replication? Do I need binary, logical, or both? Do I want to stream or ship? Synchronous replication. Synchronous replication implies that all commits must be available on the replicas before the commit will process on the primary. We do support full synchronous commit as well as quorum-based synchronous commit. For those who were in here before, they already know what this is, but quorum-based allows you to have a pool of synchronous replicas that will address commits coming in, and when those commits come in, the master can proceed, even if there are other synchronous replicas that are outside of the quorum. If you don't do this, all replicas that are in the synchronous list must process the commits before the primary or the master will take over. Or continue, I should say. Pros and cons of synchronous replication. The pros of synchronous replication are that you are guaranteed that the primary and the replica or replicas are in the exact same state at any point of failure. There is no arguing that that is valid and helpful. It is nice to know that if the master dies, your slave is exactly where the master was at the last commit. That is data integrity at its finest. The cons of synchronous replication is that you will suffer a performance penalty and potentially an outage in the event that a replica that is within the synchronous configuration is suddenly unavailable. That is a huge downside to synchronous replication. If you have a replica that decides to disconnect, the network goes down, the internet goes down, it doesn't matter. The switch port goes bad. Somebody kicks it and turns it off. It doesn't matter. Your primary will stop. It no longer works. Now, to be fair, all you have to do is remove the failed slave from the synchronous standby names list and reload. It's possible to do that. But I take issue in the fact that I have synchronous replication, so I will not have an outage. And the fact that synchronous replication can cause an outage, to me, is a con, not a pro. It is not recommended to use synchronous replication unless you have a networking interconnect that is able to move faster than the I/O that you are utilizing on the primary. That's big. Think about it. Even today, most networks, private networks, are only on gigabit. My laptop can move data faster than that because I have an SSD. So if I have a master and I have a secondary and I have SSDs, I am actually not getting the full benefit of my SSDs because the networking interconnect for synchronous replication is slower than the SSD itself. So at a minimum, realistically, if you're running synchronous replication, you need a 10 gigabit interconnect between the primaries and the secondaries. Okay? We will discuss synchronous replication more in depth in further sections. Asynchronous replication. Asynchronous replication is the most widely deployed protocol for replication. It also implies that data will commit on the primary before the replicas, and the replicas are allowed to lag behind the primary. The asynchronous nature makes this choice for most widely used for geographically dispersed installations. And it's not just that. I mean, even if you have a local primary and secondary, I would recommend async unless you have a very specific problem you are trying to solve that can only be solved by synchronous replication. Otherwise, just use asynchronous. And as you can see with the graphic, it's pretty simple. I mean, you can go across continent. I'm not sure that I would go from, say, Seattle to Moscow. I might think about using cascading replication for something like that, just from due to the latency. But certainly cross-continent or cross-country. When using asynchronous replication, there's generally no performance decrease for replication. That's true. If your network interconnect is fast enough, it is possible to achieve what some call semi-synchronous replication. And there's a lot of different definitions for semi-synchronous. My definition of semi-synchronous is that it is asynchronous replication that is moving fast enough that it might as well just be synchronous. You're not paying the performance penalty or the outage penalty of synchronous replication, but since your interconnect is fast enough, your primary is fast enough, your secondaries are fast enough, it's essentially, or in practice, synchronous. Okay. However, it is possible that in the event of a primary outage, your replica may be in a different state than the master and data loss is possible. That's absolutely true. It is asynchronous. You have no guarantees. The way you solve that problem without running synchronous replication is that you use monitoring. Monitoring will tell you, my replication is 5 seconds behind. My replication is 5 minutes behind. Why? How do we fix that? Those types of things. Binary, logical, or both. Each replication option has different operational requirements. Binary replication can only replicate an entire cluster, whereas logical replication is able to replicate partially. It is also possible to integrate logical replication into a binary configuration as well. Now, what do I mean by that? With binary replication, which is built into all versions of Postgres, is a byte-by-byte identical replication, meaning that if both your primary and your replica are stopped and in the same state, the page files, the files underneath that contain your data, on the primary and the replicas will match. And when I say match, I'm not talking about just the data inside. I mean, if you checksum the same file on the primary as well as on the secondary, and they're in the same state, that checksum is going to match. They're completely identical at the binary level. Further, binary replication is only able to replicate an entire Postgres cluster. There is no partial replication available using this option. Seems like an obvious statement, but it isn't. What it means is you can have an installation with 50 databases. Those 50 databases are used by 50 different applications. With binary replication, if you replicate, you will have those 50 databases replicated wherever you're replicating, no matter what. There is no, well, I take that back. There is one option for binary replication. Cybertech out of Austria puts it out. I can't remember what it's called, but what they actually do is read and parse the wall logs as they're being generated and allow you to binary replicate through a filter. I've never used it. Sounds kind of hacky. But, you know, sometimes there's a big red button you need to push to see if it'll work. All right, here's a sample binary replication architecture. Postgres supports a single master to many slave architecture. The architecture also extends to cascading slaves. For example, in this example, we have a master, we have a slave, and then the slave has slaves. It's a really good configuration for in a situation where the master and the slave are fast. The interconnect between them is fast. But slave 2 and 3, the master can't get to them for whatever reason. Maybe it's a firewall, or maybe the connection's too slow, or whatever. And the slave actually has a fast interconnect to slave 2 or 3. It's also good for DR, disaster recovery. It's nice to be in a situation where in one data center you have a master and a slave, and then in another data center, who knows where, you have another slave, but it's connected to the first slave because you don't want to slow down the master. You don't want the master to have to process those extra replication requests. Now, it's relatively lightweight, but it's still there. Logical replication. Logical replication is the process of replicating results of data modification. It has a particular benefit in that it can be used in conjunction with binary replication. It also has the benefit of being able to replicate partial data sets as well as cross-replicate data. It can also be used to replicate to alternate technologies such as Kafka or even MySQL. Don't do this. Use Postgres. I'm going to say that one more time. Don't do this. Use Postgres. But it's true. You can, in fact, in the logical replication talk, I have a link to the logical decoder that allows you to replicate from Postgres to MySQL. I have no idea why anyone would do that, but, you know, to each their own. Here's an example logical replication architecture. As you can see from the diagram, logical replication is exceedingly flexible in how it can interact with your users, as well as your binary replication configuration. So let's take a look at this. So if we look at the left yellow box, we've got a human resources app, plus full subscriber to SalesDB. And I won't get too much into what that is because we do talk about it later. But unlike binary replication, where you basically have a master and a slave, or if you're politically correct, a primary and a secondary. What you have with logical replication is publishers and subscribers, which have publications and subscriptions. Okay? So what we have here is a human resources app with a full subscriber to the SalesDB. The SalesDB is up top here. And that is our public-facing SalesDB, so think shopping cart or Salesforce CRM or something like that, right? So publicly, we have a read-write SalesDB that's doing everything that it does, and we are publishing that entire read-write SalesDB to the full subscriber, which is the Human Resources app plus full subscriber to SalesDB, HRDB, Human Resources DB, which is then binary replicating to a logical replication hot standby. The read-write SalesDB also, for disaster recovery, is binary replicating off to another data center. The reason we would do this is you never let salespeople near employee information. They will try to sell your own employees. So you want that information separate. HR is, you know, it's private information. It's government identification numbers, birth dates, things like that. So you're able to segregate the data out that we are replicating. All right, let's get into configuring binary replication. These are our binary replication configuration options. The two files you will need to edit for Postgres replication are the PostgreSQL.conf and the PGHBA.conf. We are assuming that your primary and replicas or secondaries are able to communicate with each other over the network, including any firewall configuration. So for example purposes, what we're assuming is that you're on an open network between your two machines. I'm not going to get into how to configure IP tables or SSH keys or anything like that. So the first thing we need to change is our listen addresses. This is the IP address you wish to bind Postgres to. By default, Postgres will bind to localhost, which will not work in a binary replication environment. You must use an IP address that's available to the replica. For example, all, the second one is obviously broken, or the third one where we're binding to localhost plus an external IP of 192.168.1.5. So again, in order for binary replication to work, the secondary must be able to connect over an external interface to Postgres. So it can't be just local host. It must be on the external interface. max worker processes. It sets the maximum number of background processes the system can support. This parameter can only be set at server start. The default is 8. When running a standby server, you must set this parameter to the same or higher value than on the master server. Otherwise, queries will not be allowed in the standby server, meaning that if it's not 8 and 8 between the primary and the secondary, your hot standby won't work. It'll replicate, but you won't be able to run queries on the hot standby, so you can't load balance or anything like that. When configuring this parameter, keep in mind the relationship, and this is extensive, between not only max worker processes, but also max logical replication workers for logical replication, max parallel workers, which we discussed in the other training. Parallel workers are for parallel query. And if you want parallel query to work, you got to have enough max worker processes, but you also have to take into account that max worker processes is affected by replication. Okay? As well as max parallel workers per gather, as they are all limited by max worker processes. An effort to determine the best value for this setting is difficult. A good rule of thumb is to take each of the above parameters, add them together, and multiply that by 2. Now, that may sound arbitrary because it is. It's completely arbitrary. But it's the only way that I could think of to say, okay, my bases are completely covered for every setting that I have that is limited by this one top setting, and I have enough room in case something else happens, like I need to run more backups, or I need to add a replica, or I want to increase my max parallel workers, or whatever. Wall level. This sets the amount of information stored within the wall for particular features, including logical and binary replication. Unless you are running a minimal system without any replication, the recommendation is to configure this setting to logical. And I agree with that. There's no reason not to have it logical unless you are under significant I/O strain. Because yes, the wall will take up more information if it's set to logical, but on the other hand, if it's set to logical, anything that you want to do that Postgres can do via the logical decoding is there. Whether it be hot standby, whether it be decoding streams to send to Kafka, whatever, it's available to you. Archive mode. This setting determines if you want to use log shipping and or point-in-time recovery. We recommend that you set this to on at all times, as it's not a performance hit and it enables the use of log shipping at any point in the future without an outage. So there are 2 points to this. One is point-in-time recovery, which we're not going to talk about, but that the setting requires a Postgres restart to change, but it doesn't do anything if it's on, as long as archive command is correctly set. That's the key. So you can have archive mode on, and if you have archive command set to anything that returns true, all right? So this is the setting that is most appropriate for modification in relation to archive mode. It only requires a reload, no outage to change, and can be set to bin true or equivalent when not in use. It can also be used for hot standby. If you are in an environment where you can ship logs from a primary, but you cannot connect to the primary from a secondary. If you are able to connect to the primary directly from the secondary, the use of replication slots is preferred. That's true. So what I'm saying here is that I've got archive mode on because at some point in the future, I might want to do point-in-time recovery. I don't want to affect my replication. But if I don't have archive command correctly set, wall logs will build up forever until you run out of disk space. Because by default, what Postgres says is, if I get a success return, I will go ahead and remove the wall log. If I do not get a success return, I will keep that wall log until I get a success return. So every time you rotate a log, and under a busy system it can happen very quickly, you are using more and more and more hard disk space. Okay? The other advantage to using archiving is in the event that my secondary, let's go back to this set here. So let's look at this diagram again. Let's assume for a moment that the arrow on the, or that the slave, that arrow is actually backwards. So the slave with this arrow, the first slave, should actually, the arrow should be pointed to the master. In normal replication, it is the slaves or the replicas that connect to the master to receive everything. But as we all know, with replication or any network environment, quite often you can go out, but you can't come back in, right? The firewall lets anybody go out and do whatever they want, but no one's coming back in through the firewall. So with archive command, what we can do is use the same facilities for point-in-time recovery so that that master, instead of having to open a hole in the firewall, will actually ship the logs to the secondary for restore. And you can use that with hot standby. Now, the downside, of course, is you're always going to be at least one wall log behind. Always. So you can't use it for synchronous. It will always be clearly an asynchronous situation. But it does allow you to get around certain... Ooh. I didn't know we were going for a romantic vibe. Okay, now I'm all... My entire environment's changed. So anyway, so the point is that you can get around certain firewall limitations. And you can also do things, and this is a very common thing now. I personally don't understand... Well, let me rephrase. I understand why. It's just not something I would do. It is very common to ship wall logs, archive logs, to S3 and use S3 to store all your logs in case of point-in-time recovery. We're not going to go into that at all. Max wall senders. This parameter is used to determine how many wall processes are created for sending a wall stream to clients. You are going to want to increase this, as it is also used for binary-based backups, such as PG-based backup and PG backrest. It is also used for streaming replication, so make sure you have an appropriate number available at all times. A good starting point is to set it to a setting equal to max background processes. It's a good starting point, but I don't think it's enough, especially when we start talking about I've got 3 replicas, I've got something doing differential backups or incremental backups, but then I also have my nightly backup, or maybe I have a development team that grabs a copy of production using PG-based backup every hour on the hour to do testing against or something like that, or maybe multiple teams. So when you're thinking about this, more is better. You don't want to overdo it because it does take up resources, but you want to make sure you have enough available. Wall keep segments. This is a historical setting for allowing secondaries to catch up from the primary in the event of an outage or disconnection. Do not use this parameter. Instead, use replication slots or archiving instead. That's absolutely true. If you can't use replication slots, use archiving. Always. Because archiving, you can keep the logs as long as you absolutely must or want, and you can have a data retention period. Wall keep segments was a good-spirited, bad implementation setting, because at no point do you necessarily know what kind of churn you're going to get in your wall. So you could end up in a situation where you think, let's say 1,000, right? We have 1,000 wall keep segments, which is 1.6 gig worth of wall. Well, what happens if you have an extended outage for whatever reason? It could be an upgrade, not upgrade to the database, but the upgrade to your software. It could be an extended outage because of natural disaster or whatever. Now, a lot of people think, well, that's no big deal. I'll just take a new base backup. Well, guess what? What if you have a 5 terabyte database? You've just extended your outage because you're going to overrun your wall keep segments, which means you're going to have to take a brand new base backup of a 5 terabyte database. And I don't care what kind of interconnect you have, that takes time. And it's not a short amount of time. Replication slots. Replication slots are an option on the primary. You create one replication slot per secondary you are going to use. The use of replication slots can also pertain to logical replication and backups. The purpose is to keep track of changes in the event of disconnection. Consider something like batch replication or outage on a secondary. It's also very useful if you have a situation where, let's say you have a secondary in Hong Kong, and the bandwidth between Hong Kong and Berlin isn't that great. So instead of tying up all the bandwidth during the business hours, we just disconnect. We're still able to report off of the Hong Kong database because it's a hot standby. It's just behind by 12 hours. And then at 12 hours, it automatically fires back up, reconnects to the primary, and because we're using replication slots and everyone's asleep or not working, we're able to sync back up and get the data, the secondary in Hong Kong, back up to date. Max replication slots. This parameter is used for backups, binary replication, and logical replication. We'll talk about logical replication later. You need this setting to be at least number of secondaries plus 5 for backups. I can't stress that enough. One of the most obnoxious problems is when you think you have enough and then you don't, and you have to take an outage. No one wants to take an outage because they need to add the amount of available ability to add replication slots, right? You don't want to have it set to 5 and then all of a sudden you need 10. And it's very easy for someone to say, oh, I'll never need more than 5. I guarantee you if you say I never need more than 5, you will need more than 5. It has to be something bigger, right? It's got to be, I'll never need more than 20, right? It doesn't hurt you to have the ability to do more, and then you're not limited when you do need to do more. All right, create a replication slot. This is done by executing the function via PSQL or any other client that you have. PG create physical replication slot. Slot name, the name immediately reserved, which is a Boolean, and temporary Boolean. Creates a new physical replication slot named slot name. The optional second parameter, when true, specifies that the LSN for this replication slot be reserved immediately. Otherwise, the LSN is reserved on first connection from a streaming replication client. Streaming changes from a physical slot is only possible with the streaming replication protocol. The optional third parameter, temporary, when set to true, specifies that the slot should not be permanently stored to disk and is only meant for use by the current session. Temporary slots are also released upon any error. So all that, acronyms, LSN, all that stuff. Here's what we're really talking about. The slot name's obvious. We can name it My Backup, My Replica, Replica 2, whatever. It's whatever is valid to your particular configuration. But it's the second one that's important. And it's a very common mistake that people make. If you create a replication slot and you set the second value to false, or you do not use the second and third value, and then you take a base backup, your base backup will likely be invalid by the time you're done. Because the replication slot will not record the wall logs until you connect to it for the first time. It's also something that's easy to forget. I just 3 months ago, was working on a client. I was trying to update their staging server, and I ran a base backup 3 times, all connecting to the replication slot, and it wouldn't come up. And for the life of me, you all have these moments where you feel really stupid when you remember what the solution was. But I was beating my head against the wall, and so I did what every good person does, and I asked one of my employees, what did I do wrong? And he's like, dude, you didn't set it to true. So I went back and read the docs, and sure enough, I had just forgot this true statement. And what true means is the moment you create the slot, start recording. That's basically what it means. In practice, start recording the moment you execute, and then you start your base backup so that when you connect, the base backup can catch up. Drop a replication slot, simple enough to do. PG drop replication slot and the slot name. Doesn't take any other parameters beyond that. Drops the physical or logical replication slot named slot name. Same as the replication protocol command drop replication slot. For logical slots, this must be called when connected to the same database the slot was created on. Now, we're not going to get deep into this until later, but the reason for that is that we are not replicating the whole cluster in logical replication. You are replicating a publication and a subscription, which could be in any database. And since databases are isolated from each other, it would actually be possible to have 2 different slots name the same thing in different databases if they're logical slots, not physical slots. We want to view our replication slots. It's simple enough to do. To view what replication slot you currently have in their status, a simple query to the system table, PG replication slots will suffice. As you can see, select star from PG replication slot. There's my slot name, subscriber 0. Plugin is if you're using some kind of logical decoding plugin. It'll tell you what it is. The slot type, it's a physical one, not a logical one. And the data ID and database aren't really relevant in this context. And then whether or not the slot is active. There's a couple of other things in there, but this is just an example. Okay, this is a whole mess of words here. Synchronous standby names. We've talked about this a little bit already. Specifies a list of standby servers that can support synchronous replication. There will be 1 or more active synchronous standbys. Transactions waiting for commit will be allowed to proceed after these standby servers confirm receipt of their data. This goes back to what we were talking about with synchronous replication, in that the primary cannot move forward, cannot process data, cannot allow your application to work if there are pending commits on the slaves. Okay? The synchronous standbys will be those whose names appear in this list and that are both currently connected and streaming data in real time, as shown by a state of streaming in the PGStat replication view. We talk about that a little later. Specifying more than 1 synchronous standby can allow for very high availability and a protection against data loss. I don't agree with half that statement. It is absolutely a protection against data loss. But the fact that a non-moving secondary can cause an outage of the primary makes it so it's not more highly available. The name of the standby server for this purpose is the application name setting of the standby. You set that in the recovery.conf. We'll get to that later. As set in the standby's connection information. In case of a physical replication standby, this should be set in the primary con info setting in the recovery.conf. The default is wall receiver and should be changed. That's absolutely true, because what will happen is that if you just use the default across all your replicas, when you look at your stats, the statistics for your replication, they will all be identified as wall receiver. And you won't necessarily be able to tell which one's which. Lost my train of thought. Yes, okay. All right, so if we look at this a little bit, if we look at, it's kind of hard to see from the back probably. We got our first numseq standby. That's where you're starting to get into the quorum type commit. I don't know of any, I'm not saying they don't exist. Don't get me wrong. I'm not saying they don't exist. But of all of my clients, not a single one of them uses synchronous replication. Every single one of them that has thought they needed it ran it for about a week and turned it off. Every single one. Now, don't get me wrong. If you're doing stock trades, financial data, streaming data of critical nature, it makes sense. But as far as I can tell in my experience, it's about a 1% proposition. Of all the installations of Postgres in the world, of which there are literally millions, 1% actually need synchronous replication. In fact, I would argue that synchronous replication exists within Postgres not to solve any technical problem, but to solve a marketing one. Because if we don't have synchronous replication, somehow we're not as reliable or enterprise grade or able to compete with evil Oracle or something like that. So if we look at the setting here, it says where numsync is the number of synchronous standbys that transactions need to wait for replies from, and standby name is the name of a standby server. First, in any, specify the method to choose synchronous standbys from the listed servers. The keyword first, coupled with numsync, specifies a priority-based synchronous replication and makes transaction commits wait until their wall records are replicated to numsync being a variable number of synchronous standbys chosen based on their priorities. For example, a setting of first 3 S1, 2, 3, 4 will cause each commit to wait for replies from the 3 higher priority standbys chosen from the standby servers S1, S2, S3, S4. So I'm going to highlight this. So when we look at that, what we're saying is that we must have committed 3 on the first 3, 1, 2, 3, before we can move forward of the 4 synchronous standbys. The standbys whose names appear earlier in the list are given higher priority and will be considered as synchronous. Other standby servers appearing later in the list represent potential synchronous standbys. If any of the current synchronous standbys disconnects for whatever reason, and this is actually pretty cool. If any of the current synchronous standbys disconnect for whatever reason, it will be replaced immediately with the next highest priority. The keyword first is optional. So in practice, what we're saying here is we must commit on 1, 2, or 3 to move forward. 4, it would be nice if we did it. But more importantly, and this is where you do get higher availability in the newer versions, is that let's say S2 disappears. S4 will everything will just move forward to the left, synchronous replication continues, and the outage does not occur that happens with synchronous replication. If any of the current synchronous standbys disconnects for whatever reason, I already talked about that. The keyword any, coupled with numsync, specifies a quorum-based synchronous replication and makes transaction commits wait until their wall records are replicated to at least numsync listed standbys. For example, a setting of any 3 S1, 2, 3, 4 will cause each commit to proceed as soon as at least 3 standbys of S1, 2, 3, or 4 reply. This is pretty much how Aurora works. Amazon Aurora. They actually do their storage across multiple volumes, and then they have a quorum of what they accept for the database to move forward. First, and any are case insensitive. If these keywords are used as the name of a standby server, its standby name must be double quoted. The third syntax was used before Postgres version 9.6 and is still supported. It is the same as the first syntax with first and numseq equal to 1. For example, first 1, S1, S2, and S1, S2 have the same meaning. Either S1 or S2 is chosen as synchronous standby. Special entry star matches any standby name. All right, next we need to edit the pghpa.conf. This is a pretty simple file as long as you don't try to use external authentication mechanisms. The pghpa.conf is the Postgres host-based authentication file. You will need to configure this file to allow for your secondary or replicas to connect to the primary to receive the replication stream. The file looks like this. As you can see, we have local all Postgres using peer level authentication, peer being in order to connect the database that you're connecting to must be named the same as the user that is connecting. It's fine for local stuff. Don't use it for anything else. Local all, peer, host all, local host, MD5. Now, in 9.6, MD5 was relevant. In 10, you really shouldn't be using MD5. You should be using SASL. And I think with SHA, I think it's 256. But for the case of making this easy, we're going to stick with MD5. We also have an IPv6 local connection. Anybody in here actually using IPv6? Anybody? What was that? Oh, you're using it? Okay. Well, that's good. I mean, so I like the theory of IPv6. I certainly don't like how it addresses. I wish they just used just like Class C type stuff to make it easier to read. Okay, but the bottom lines are what we're really concerned with. Allow replication connections from localhost by a user with the replication privilege. That's the local there. And then the second line, host replication all, localhost MD5, and then obviously it's the localhost for MD5, or sorry, for IPv6. What we need to do is open this up to the world, or at least our internal network, so that we can connect. Particular line we need to change, we need to modify is one of the last three where we are allowing replication. In this example, we want to change the replication lines to something like the following. Local replication all, peer, and then host SSL, replication all. We're allowing 192.168.1.5 to connect over MD5. Notice I changed that to host SSL. I think even internally, even if you have a closed network, you should be using SSL. There's a number of reasons. On Ubuntu, you don't get the compression advantage. I don't know if you do on CentOS. Does anybody know, actually? Does CentOS, did they re-enable SSL compression? No? Okay, well, at least on Ubuntu in the current versions, it does not. And it has to do with a security hole. But more importantly, if you look at studies of industrial espionage, it's something like over 70% happens internally, not externally. So you should protect your streams at all time, encrypt everything. Once you've edited the file, and if you were in the previous class, you'll know this, you can reload the settings with the PGConf reload function as a super user, just from PSQL or whatever other query tool you've got. Just say select PG reload conf. It'll return true or false. If it returns false, there's a problem. Go look at it. If it returns true, you're good to go. Your secondary configuration. The following parameters need modification for a secondary to be brought online. Hot standby. Will the secondary be a hot standby? I don't see why you wouldn't have it be a hot standby. I mean, it's read-only queries anyway, so you might as well just have a hot standby. It makes it more useful. Enabling a secondary for hot standby allows a replica to execute queries in a read-only manner. This can be particularly useful for load balancing or reporting. It is possible to load balance between primaries and secondaries that are on a hot standby, keep in mind that unless it's logical replication, your hot standbys will only be read only. You will not be able to do anything but reporting in just select queries. There's a couple tools out there that allow you to do that. You got PG Pool, you've got Heimdall Data, you've got, I think there's one called SQL Proxy or something like that. And it's also easy enough, if you know what your hot standbys are, you can just have a different connection class for whatever application you're running, so that if you know that the application is, or the query being run is only going to do reads, or you just use that connection class instead of your read-write connection class. Max standby archive delay. Configure this setting when you are not using streaming replication to a hot standby, but instead are using archiving. In short, the secondary will wait this long before canceling a query on the standby. You can set this to -1, which will cause queries to run indefinitely. However, that is not a practical setting, as it will cause bloat on the primary, as the primary keeps all changes that are unable to be applied because there's an open transaction. Does anybody here understand the problem with long-running transactions yeah? Okay, so Postgres, and it's better at it now, but it still has a very significant limitation. If you, sir, log into Postgres on a Friday at 3 p.m. and you say begin semicolon, and then you get distracted by cat videos on the internet, and then you go home, routine maintenance will not work all weekend. You will bloat out your database because you have a long-running idle transaction. This is a very similar problem with hot standbys, in that you've got queries running. Each query is a transaction. So if you have a long-running report, so a report takes 4 hours, the primary is keeping track of all changes that it must ship to the standby that it can't while that transaction is running, which means that the things that aren't being processed are very similar in that it can't do cleanup. The primary can't do cleanup and ship logs to be applied for cleanup because the transaction may still need the rows that are visible to its snapshot. Does that make sense? Okay. Max standby streaming delay. This is effectively the same setting as max standby archive delay, except it applies only to streaming replicas. I should make that distinction. So archive delay is if you are using archive mode on and archive command to ship your replication information. Whereas max standby streaming delay is the the reverse, where you are using streaming replication, which means the secondary is connecting to the primary to receive its replication information. Okay? Just as a side note, I know you all weren't in here, but you completely cleaned us out of our mammoth stickers, which is kind of cool. I'm glad you guys did that. A note about the delay settings. The setting is not the same as the maximum length of time a query can run before cancellation. Rather, it is the maximum total time allowed to apply wall data once it has been received from the primary server. Thus, if one query has resulted in significant delay, subsequent conflicting queries will have much less grace time until the standby server has caught up again. So we're not talking about disconnecting replication or killing a query. What we're talking about is we had a long-running query that had all this information backed up. We've now, the query's finished. We've shipped or streamed all the new information. Other queries might get canceled because that information hasn't yet been applied. Wall receiver status interval. Tell the standby how often to update its master on the current status. If set too high, PGStat replication will be out of date, and you may overrun replication timeout on the master. So wall receiver status interval says, hey, standby, I'm a standby, I'm going to let the primary know my status every X seconds or milliseconds. And if I set it too high, PGStat replication, which tells me how far behind my standbys are, won't necessarily be accurate because it hasn't received an update from the interval, or an interval from the update. If I said that right. Hot standby feedback allows the standby, including cascading standbys, to tell the master what queries are being run so that the master doesn't remove rows during cleanup and cause a query cancellation. This can cause bloat. Okay, so this says, I'm a hot standby, I got all kinds of things being run, I need to make sure that the new information coming across from the master doesn't remove the rows from the snapshot that I'm currently working in. However, because of that, depending on what's going on, it can cause bloat because the primary is holding on to all that information, waiting to ship it across. And since we have in BCC, we end up in a situation where we have many versions of the same data because it'd been modified, changed, nothing's been committed, that type of thing. Wall receiver timeout. The amount of time to wait for replication connections that are inactive before disconnection. I think that's pretty obvious. If not, please let me know. But I think that's probably the simplest of all of these except for hot standby on. Wall retrieve retry interval. Specify how long the standby server should wait when wall data is not available from any sources, streaming replication, local, PGLexlog, or wall archive, before retrying to retrieve the wall data. The interval is not so much interesting as the fact that you can have multiple sources delivering the same information. For a long time, in fact, until replication slots came about, my recommendation, and in my opinion, the best practice for replication, binary replication, was that not only did you stream to the secondary, you also shipped your logs via archive command to the secondary. And the reason you did that is because if your connection dropped, those wall logs could still be applied even if you overrun something like wall keep segments, the old wall keep segments, because you're still shipping those logs all day long, and if you can't ship them, it's like a global replication slot because Postgres says, I can't ship this log, so I'm going to keep it. I can't ship this log, so I'm going to keep it. Then all of a sudden the secondary comes back up, it ships all the logs over, it catches back up because it has the logs, and then can connect to the primary to start streaming again. Okay? Nowadays, that is not quite so important because you have replication slots. And replication slots are machine distinct, basically buckets of archive logs. All right, now that we've done all the talk, not all the talk, but while I'm hydrating, does anybody have any questions? Yes. I know you. I don't know why I know you, but I know you.
Добрый день.
Hold on, I need. Where's the translator thing?
Добрый день. У меня вопрос про настройку PGConf. Вот у вас слайдик был по этому поводу. Я хочу спросить, допустим, у меня есть репликация, несколько реплик. Я хочу, чтобы на одну из них реплика шла через SSL. На все остальные без шифрования. Как мне прописать это в PGConf? То есть что я должна там указывать? Понятно?
Okay, so basically you want to be able to run SSL over one connection, but not over all of them. There's a couple of ways that you can do this. The simplest is, and I talk about it a little later, but the simplest is that you can tell your recovery.conf in the connection info, you can say SSL mode require or SSL mode try or none, and then whatever secondary is connecting, based on the connection string itself, it will determine whether or not it's SSL encrypted. That's one option. The other option is you can actually, in the hba.conf, force it. So you can say, in the hba.conf, you just say host, and then the IP address of each secondary, and if you just use host, it won't require SSL. And then for the host that you want to require SSL, you just say host SSL, and then in the connection info you connect. Does that make sense? Okay. Any other questions? Yeah.
Можем ли мы использовать логическую репликацию между базами данных, которые немножко отличаются? Например, в базе данных, которая в стендбай, отсутствуют некоторые таблицы или отсутствуют некоторые колонки в таблицах. Это первое. Второе. Можем ли мы воткнуть middleware?
Let me answer one at a time. Let me answer one at a time. Okay, so we will talk about this a little further in logical replication, but yes, you actually can. That's the whole point of logical replication, is that you can do weird stuff like that. You can replicate a single table. You can replicate a group of tables. In terms of the column missing perspective, what has to happen is that you can have, let me see if I can say this correctly. On the subscription, you can have more columns, but you cannot have less. So you can have a situation where a publication will replicate, let's say you have a table on your primary, on your publisher that has 3 columns. And you have the same table on your subscriber and it has 5 columns. As long as the order and the 3 columns match, it will replicate. But you can't do it the other way. So you can't have less, but you can have more. Does that make sense? Okay, what's your second question?
Второй вопрос. Мы можем вставить какой-нибудь middleware между мастером и стендбай при логической репликации так, чтобы мы могли самостоятельно транслировать, преобразовывать эти запросы?
Interesting. You could. What you would do is have a custom, and my business card's right over there, we can help you with that, a custom logical decoder. And what it would do is connect to your publisher and read the stream, and then you could tell it based on the stream, do whatever. For example, it could say, the publisher will say, I am sending publication X. And we could configure that logical decoder to say publication X actually doesn't go to Replica, it goes to Kafka. But publication Y goes to the Replica, which would be the subscription. Yes, you could absolutely do that. That's the glorious thing about logical replication, is that all logical replication is the decoding of the logical stream from the wall going somewhere, wherever it is. Now, in this case, we're only talking about Postgres, but we can absolutely send it anywhere because we can decode it. Any other questions? Can someone grab the mic?
Представим ситуацию. У нас есть мастер, slave, вот, и валы мы хотим накатывать не архивами, а это у нас общий диск. В таком ситуации, ну, то есть такой конфигурации мы можем сделать? Когда у нас валы у нас на одном диске, и его читает и мастер, и slave.
No. I'm going to say that one more time.
Почему?
No. It's a common. It's actually an old. It's if you've been doing this as long as me, it's called the shared disk idea, right? Shared disk high availability is one of the ways it does that. Postgres can't do that. I mean, theoretically, it would be possible, but it wouldn't be reliable because the master is going to control what happens to those wall logs. And then you're going to get conflicts because the secondary is going to think it's in one state, the master is going to think it's in another state, and it might remove one of those wall logs, and then all of a sudden the secondary is dead. It won't work. And you wouldn't really want to do that anyway because it's going to reduce reliability. Now, you could use shared storage for something like point-in-time recovery. Right? You absolutely could do something where you have shared storage for archive logs and you're restoring from multiple sources from a single source. That you could do. But from a replication perspective, no, that's a bad idea.
Из-за того, что slave удалит, да, вал?
Well, either one might. That's the thing, is either one might, and you don't know when or what. So the master might remove it, and the slave doesn't have it. Or the slave might, if the slave removes it, as long as the master's already used it, the master's not going to care. But either way, what you're doing is you're creating a double dependency from a single source, and it's not going to work. Next, I think right behind you.
If we use binary replication, we can run read-only query on slave. But if query is heavy and run for a long time, it stops replication into slave. Can we use some, or is there exist any version mechanism that can save copy of page into some location in order to provide them for this long query?
So, no, not really. I mean, the way you would do it...
not to stop and blocking, but same as Postgres version mechanism, likely.
Right. So I think what you're asking me is what we were just talking about with how a hot standby with a long-running query, it will basically, it doesn't stop replication, but it effectively stops it, where the standby is not receiving updates because of an open snapshot. There's no real good way to deal with that without, you got to set your settings low enough to where the long-running query won't be an issue. What I find is most useful is to have multiple replicas, one where it is OLTP only, right? So you have your primary and your secondary, and they're both OLTP only, which means the queries are always going to be as fast as they are going on the primary. And then you have another replica, which is going to be your reporting server. Mm-hmm. And that one, you just got to accept sometimes might be behind.
Thank you.
You're welcome. All right, anything else before we continue? Yes.
Okay, thanks for the half part of great talks. And you told about the situation when we have one master or one slave for this primary base and two slaves, 2 and 3 for first slave. And as I remember, Postgres can dynamically redirect 3 or 4 slaves to the master if we lost second slave, yes?
Yeah, it's called timelines.
Yes, and that's why I have a question. If we give 1 slot for our slave and we lost him, we have, for example, 3 slaves which retrieve data from first slave, and now he tried to get this archive from master.
Say that last part one more time.
Okay, we have master and 1 slave for this master, and a few slaves for first slave.
So you have a master, and then you have a slave, and then you have a couple of slaves that are connected to
yes, schema on second page.
So the cascading.
Yes, yes, and we lost first slave.
Okay.
Can Postgres dynamically force to other slaves takes data from master?
Okay. So I'm going to say back what you said for
yes.
everybody. As I understand what he's saying, or asking, if you take, let me check what page I'm on here so that I don't miss this. 15. Okay. So if we go all the way back up to the binary replicate, here we go. This guy here. So what he's asking, we have our master and our slave, and then we have slave 2 and 3. What happens when slave 1, let's just, for whatever reason, it dies? Can we make slave 2 and 3 reconnect to the master and just proceed? Is that correct?
Yes.
Okay. The answer is yes. I can't tell you exactly how it's done. I know that there are some issues in that. One, you need to make sure that you have the logs, because likely slave 0 has already consumed those logs, and slave 3 and 4, that is 3 and 4, or 2 and 3, will need those logs in order to connect to the master and be up to date. So you would either have to be archiving, where the slaves would know, okay, I can't connect and now I can connect, and restore those in like a point-in-time recovery situation, or you would have to have a scenario where you have a couple of replication slots that are doing nothing until they connect. And secondly, there's another part of this that has to do with timelines. That's the part I'm not real clear on. But yes, it is possible. I just don't know exactly how to do it.
Okay, thanks.
Okay, anything else before we proceed? Oh, there's another one.
So, if master will down because of internet connection or something, can the replica dynamically upgrade to master?
Yeah, absolutely. And we talk about that a little bit. Basically, in your recovery.conf, or not your recovery.conf, there's one, you can do it through your monitoring software, of course. But there's a command, it's PGCTL promote. It's literally that simple. And it will promote whatever hot standby or slave to a master. And then there's also another opportunity. It's called a trigger file. And that basically you tell the recovery.conf, if this file exists, promote. And so you can have a situation where your monitoring software, for example, you detect that the master is down, you double detect that the master is down. So you know for a fact that machine is down, it's not coming back. And then you literally just touch, the command touch, the trigger file. Postgres will detect that the trigger file was created and promote itself to a master.
Thank you.
You're welcome. All right, so we're actually at break time here. I can take one more question before break, but then we'll break for coffee or afternoon, whatever they do here. Anything else? All right, see you in a half an hour. Thank you.
Joshua, please tell me, is it possible to use simultaneously archive command and replication slot? For example, archive command for backup and point-in-time recovery, and replication slots for replication.
Yes.
They don't interfere and no. Thank you.
Okay, I'm going to go ahead and try and get through the rest of at least this part of the curriculum. As a reminder, if we don't get to the logical replication part, and depending on what happens, I might just cut it off so that you guys can ask questions instead, because I've got, I really enjoy an interactive crowd, and you guys have a lot of questions, and I like us all learning from each other. So I'm going to try and get through at least the binary portion, and depending on what time it is, we'll do some more questions. And if you guys don't have questions, then I'll move on to the logical replication portion. If we don't get to logical replication, as a reminder, it is the exact same content that I am giving tomorrow. I think it's 2 p.m. So we can do that again. It's not a big deal. Okay, so we're configuring the secondary here. The first thing that we have to do is be able to take a PG-based backup, or a base backup of the primary. So first, we're going to assume that our primary is at IP address 192.168.1.10. I'm just going to say 10 and 5 from now on, just to keep things simple. We will need to ensure that our secondary, which is at IP address 5, can access the primary. We do this by editing the pghba.conf. As you can see here, we got local replication all peer, host SSL replication all 192.168.1.5 MD5. I am opening up Postgres to allow connections from .5 and .5 only. Now keep in mind this is a IP/CEDAR address, so it doesn't have to be a single IP. You could open it up to a whole network just by changing the net mask. Okay, it's just I'm keeping it simple. The above will allow any role who has the replication attribute. This is the key. You have to have the replication attributes. So when you create your replication user, I'm cheating here. I'm just going to use Postgres. You probably shouldn't do that. You should probably have a separate user for replication. But just for simplicity's sake, when you create the role, you would say create role foo, log in with replication. Okay, and it means that the user that you are creating has the ability to connect to Postgres as a replication user. Once I've made that change, I've saved it to disk, I need to reload the configuration file. Now, there's a couple of ways to reload the configuration file. The first one is you can grab the PID of the parent postmaster process and you can hup it. Don't do that. That's a recipe for disaster. It works every time until you accidentally type the wrong command and you kill it. So don't do that. The other thing is if you run on Linux, you can use like Systemctl reload on the Postgres service. I don't like that version. There's nothing wrong with it, but I don't like it because I don't like anyone to log into the database server unless required. And when I mean log into the database server, I'm talking about the OS. Now, obviously, I'm already at the OS level because I had to edit my pghba.conf, but I want to limit how much time I'm in the OS of my database server at any given point for reliability reasons. So I'm in PSQL. I say, hey, I'm going to connect port 5433. And it tells me I'm connected. And I say, select PG reload conf. It is returned true. Therefore, I know that all current changes to the PostgreSQL.conf, the PostgreSQL.auto.conf, the PGHBA.conf, as well as a couple of others that we won't get into, any settings that can be changed via a reload have been changed, and that includes these network settings. Now we're going to talk about PG-based backup. PG-based backup is a great utility. It has its pros and cons. Do I cover that? I thought I did. I had a huge paragraph about it. I guess I forgot. I may have accidentally deleted that paragraph. Okay, so what is PG-based backup? PG-based backup is a utility that ships with Postgres. It is highly inefficient, but it's fine for what it does. If you have a large database, and when I say large, I'm not talking about 50 gig. 50 gig is not large. I know it feels big, but it's not. I'm talking 500 gig. If you have anything that's 500 gig, maybe even 250 gig or larger, consider using something like PG Backrest or PG, I think it's called PG Pro Backup, which is from Postgres Professionals, because it will do a multi-threaded copy, which means that you're going to be able to utilize as much of your resources as possible, and you'll get the copy done faster. But if you're under that, if you don't mind that the base backup might take an hour, for example, PG base backup is just fine, and it makes things pretty darn simple. Let's walk through some of these options. So obviously the usage is PG base backup option. Option 1 is -D, receive base backup into directory. And that is exactly as it says. If you say -D data, when it connects, it's going to pull that base backup right down to your local machine into the directory data. And when you are done, if you do nothing else, and you were to say PGCTL-D data start, a base backup of Postgres would come up. Okay? -F format, do we want plain or tar? For this purpose, we want plain, because we're not actually taking a backup. We're actually creating a replica. If we're creating a backup, something that we want to archive, send off to tape or Glacier or whatever, then you would use tar, because it would wrap it all up into one nice little ball, and you could take that ball and put it on a remote drive or whatever you need to do. Max rate, you can set the maximum transfer rate into the data directory, whether it be kilobits or megabits or whatever. This is an interesting feature to me, and it's actually the opposite of what I expect or want. And that when I take a backup, I want it to go as fast as possible. I want my backup started and done and reliable. However, we have to recognize that not all infrastructure can support pushing 120 megabytes a second across the wire. Sometimes you got to slow it down. This is one reason why you really want to consider a situation where the public interface to your primary is not the same interface to your secondary. So in hardware terms, we want ETH0, Ethernet 0. That's where my application and my users connect. But Ethernet 1 is where my secondary connects. That way, as long as I don't overload my disks, I can transfer my backups as quickly as possible. Write the recovery configuration. This is a nice utility in that if you say write recovery configuration, it will automatically create a basic recovery.conf to bring up your standby. It's not going to have everything you need to actually connect for streaming replication necessarily, so you definitely don't want to double check it. You don't want to just start it, right? Slot name, replication slot to use. The replication slot must exist ahead of time, but you can, instead of streaming or fetching the X logs via the PG base backup utility, you can tell it when you write the recovery.conf to go ahead and connect to the replication slot so that it will catch up when you start it. No slot, prevent the creation of a temporary replication slot. So if you don't use slot name, but you use no, and it will create a temporary replicate. Remember when we were talking about replication slots, we can create a temporary one. That slot would only, since it was temporary, would only exist for the session. That's what we're talking about here, is PG base backup has connected, it's pulling a backup and it's created a temporary replication slot for that session so that you can get all the logs. Table space mapping, old dir, new dir. So one of the problems that we have is that a base backup, since it is a binary identical backup to the primary, you can't necessarily put the base backup in a different location on your secondary. It's going to assume, if you're using table spaces, that the literal paths still exist. So if on the primary you have a table space of, say, foo, and it's in /foo, but /foo doesn't exist on the secondary, it's going to fail when you bring it up. So what you're able to do is remap foo to, say, bar, so that it won't fail. Wall method to fetch or stream. Include required wall files with specified method. You definitely want to do that. Location for the write-ahead log directory. If you by default move the wall directory. Gzip, if you're using tar output, do you want a gzip? This is actually one of the reasons why I don't like PG base backup for normal backups versus just a base backup, because gzip is slow, and it's actually not that. I mean, it's a decent compression algorithm, but there are better ones. What I would love to be able to implement here is how, I don't know if you folks have seen this, but with the normal tar utility, you can tell it to compress, but then you can also tell it which compression to use. And have you guys ever heard of PGZ? Okay, PGZ is parallel gzip. You can actually tell it, hey, I have 16 cores. I'd like to use 12 of those to compress my data so that it goes much, much faster. I wish PG base backup would allow us to do that. And then obviously your compression level. General options, checkpoint, fast, or spread. This is very important. By default, if you say checkpoint spread, when it starts the base backup, it is going to use checkpoint timeout divided by checkpoint completion target to issue the checkpoint. And if you have a checkpoint of 2 hours, a checkpoint timeout of 2 hours with a checkpoint completion target of 0.5, it is going to take an hour for your backup to start. So instead, you can pass fast, in which case it will immediately just checkpoint. Now, the downside to that is, depending on how many dirty buffers you have that need to be written out, it can be a short but significant performance hit. I mean, you're basically just all of a sudden trying to shove, a gallon of water down a straw. So you do need to be aware of that and be careful. Label, set the backup label. When you use the manual ways to do this of PG Start Backup, you have to set basically a title of the backup. No clean, do not clean up after errors. That's useful if you're trying to do debugging. You get an error, it aborts out, by default cleans everything up. Well, then you could run it again with no clean, and then you can find out why did it die. No sync, do not wait for changes to be written safely to disk. It's kind of like running with Rsync off, but I would be more inclined to be willing to use this option because it does reduce the amount of I/O on the backup itself. Progress, show your progress. Verbose, be verbose. Version, who cares? Show this help, then exit. And then, of course, your standard connection option string. So you got your database you want to connect to, what host, what port, time between status packets sent to the server, connect as a specified database user, don't prompt for a password, or force a password prompt. The force a password prompt is a legacy thing. There were some versions way, way, way back where for some reason, if a client would connect, every once in a great weird while, I don't know if it was a race condition or something, it wouldn't prompt for the password and you could never log in. So they added this feature, and now you can force a password prompt. I have never actually, in 20 years, I've never actually seen the bug happen, but I have seen reports of the bug happening, which is why it's there. I have not seen it in any recent iteration. In its simplest form, taking a base backup can be as simple as this. PG base backup -H 192.168.1.10 hyphen or -U Postgres -D data, put my backup into the data directory. I need to connect via 5433, and I need to stream my Xlogs. This will place a complete base backup within the directory data, ready to go with whatever modifications I want for hot standby. That's your standard way to do a PG base backup. And I am definitely missing a paragraph. Apologize for that. The second way is an Rsync method. Anyone who's used Rsync knows the glory of Rsync. It is a wonderful, yes. Oh, you were just saying I've used it? Okay. I'm sure, who here hasn't used Rsync? Oh, you're Windows people though, right? No? Okay, so Rsync is fantastic. You should use Rsync instead of CP. You should use Rsync instead of SCP. You should use Rsync instead of SFTP. And if you're on Windows, God help you, use Robocopy. It's a very similar thing. The great thing about Rsync... Oh, sorry. So the great thing about Rsync is that, one, it verifies the copy. Okay? It makes sure that what you have over here that you put over here is identical. It also does incremental updates. So if the copy fails and you restart it, it won't recopy the previous stuff. Things like that. So if we're using the Rsync, it's also easily scriptable. So if we're using Rsync, it is a popular method for creating base backups. It's useful in that it can be used to verify the backup while it is being archived. It also uses the SSH protocol by default, which allows for a lot of customization. However, the use of Rsync does not work out of the box, and it's best that it be scripted if it's to be used more than once. Specifically, what I liked about scripting Rsync is that a member of my team created a multi-threaded Rsync. So when we're copying 5 terabyte, 10 terabyte, 20 terabyte databases, we are not copying over a single thread. We can say use 4 or 8 or 12 as long as we have enough I/O in order to do that. So here are the steps to a successful Rsync backup. We'll assume that you understand SSH authentication, either via SSH keys or password. If you're using passwords for SSH, you're doing it wrong. Use keys. That's kind of the whole point. As previously mentioned, the use of Rsync does not cover a lot of implicit features that are included in PG-based backup. Therefore, we must execute a few steps in advance for an appropriate backup. So the first thing we want to do is we want to create our replication slot for the backup. PSQL-U Postgres-H 192.168.1.10. Select PG create physical replication slot. My backup true. Remember when we first talked about creating a replication slot, we want the true there so that it immediately starts recording all the changes that you're going to need to bring up a standby. If you don't put true there, it won't record until you connect, at which point your backup is already invalid. Okay? So it shows that I created it. Boom, there's my backup. There it's LSN location. Don't worry about that. It's not even really all that important unless you're doing debugging. Select slot name, slot type from PG replication slots. Boom, there it is. Slot name, my backup. It is a physical. It's ready to go. I have verified it's there. I can now move on to the next step. In this example, we've connected to our primary and executed the function to create the slot. Talked about that already. Now we need to start a base backup on the primary. Now, of course, we could have done this in the same session. I'm not saying that you should disconnect and then reconnect, but just for the sake of example, in this example, we have connected to the primary at .10 and executed the admin function PG start backup. The first argument is the backup label, basically the title of the backup. The second is whether or not to execute a fast or spread checkpoint, as discussed in the PG-based backup syntax. Again, if you don't say true when you start the backup, you're going to do that long backup because of the checkpoint. It's going to be checkpoint timeout divided by checkpoint completion target. If you say true, it will complete the checkpoint as quick as it can, but it may be a performance hit. With the primary now in backup mode, we can start our base backup with Rsync. Using Rsync to create the backup for the secondary. The Rsync utility is fairly sophisticated, and we will not go through all the options. In a reasonable configuration, retrieving your backup from the primary would be as simple as rsync-auv, user @10, : the location of my data and where I want it to go. So I am copying using SSH. I am on the secondary. I've connected to the primary, and I'm pulling all the data down. Now, I connected as Postgres for a reason. It's because Postgres owns all the files on the primary. You can't use an unprivileged user. It would have to be whoever owns the files. So on Linux, it'll be Postgres. On FreeBSD, it would be something like PGSQL. Okay? In the above example, we are archiving A, updating U, and being verbose, V. Not necessary. V is not necessary. And if you're scripting it, I don't recommend that you use V because it just creates a lot of erroneous output. It's not even erroneous. It's just not necessary. But for this example, it's useful. And archiving the directory var-lib PGSQL data into the local directory data. When complete, we now have a base backup. There are still a few more steps. It is also possible to add additional useful flags to Rsync, including compression, or what level of compression, and different types of checksum features for added data integrity checking, for example, checksum. Stopping the base backup. Since we've completed the base backup, we now need to stop the backup on the primary. So we do PSQL-U Postgres-C select PG stop backup. In the above example, we have stopped the backup, my backup. Note that only a single backup at a time can be running, so you don't need to worry about a possibility of you stop a backup and you stop the wrong backup. You can only, now when I say backup, I'm talking specifically about base backups. Logical backups with something like a PG dump or a PG dump all, you can run multiples of those at a time. But binary base backups, you can only run one at a time. I apologize. I haven't spoke for this long. I did, as you know, I did a training in the morning too, and now this afternoon, and throat's getting a little sore. So now that we've stopped the backup, we need to create the recovery.conf. One of the final steps of configuring replication is to create the recovery.conf file within the data directory on the secondary. And when I say data, I really should say cluster, because I don't want to confuse you. It doesn't have to be named data. But wherever you put the base backup is where you need to create this recovery.conf file. There are quite a few options for the recovery.conf file that apply to not only replication, but high availability and point-in-time recovery. Within this curriculum, we are only going to cover the ones needed for replication. But I will bring up just a couple with the point-in-time recovery because they're very, very useful. With point-in-time recovery, you can restore not only to a point in time, but also to a point in transaction, for example. Meaning, if you know the transaction ID of right when everything blew up, you can restore to exactly that point to figure out what's going on. You can also use what's called restore points, meaning that you can, and this is actually really good for developers. You can have a situation, let's say you're about to deploy a new version of your application on Postgres. And you've got this massive transaction that runs that alters this table, drops this column, updates these rows, does all this stuff to bring your magical application that's going to make you independent billionaires, up to V2. Well, one of the problems with doing that is what if something goes wrong? Well, the nice thing is you can say, I'm going to create a restore point and name that restore point, then do everything. And if the world blows up, you can literally restore just to that named restore point that you know is right before you broke it. It's a very comforting feeling, if you want the truth. All right. First and foremost, standby mode specifies whether to start the Postgres server as a standby. If this parameter is on, the server will not stop recovery when the end of archive wall is reached, but will keep trying to continue recovery by fetching new wall segments using restore command or by connecting to the primary server as specified by primary con info. Now, what do they mean by restore command and or connecting? I believe one of the gentlemen asked about can archiving and replication slots work together, right? That's what we're talking about here. You can actually, while you're taking the base backup, be shipping logs to the standby and configure it in a manner that instead of connecting over the network to get everything from the replication slot, it will restore from the archive logs it already has until it can't, and then it will connect and get all the updates. It's actually a pretty useful way to do it, depending on what kind of resources you have available. The next is your primary con info string. Now, I'm actually skipping over a piece here. This specifies a connection string to be used for the standby server to connect with the primary. In our case, this is what it looks like. It's primary con info, host equals .10, port 5432, user is Postgres, and I'm requiring SSL. Okay? The part that I'm skipping is it doesn't have to be the whole string. You can use what's called the .pgpass file. And the .pgpass file is particularly useful because it's basically the primary con info for every single server you're allowed to connect to. So if I said, I'm just abbreviating here, PSQL.10, it would go to the PGPass file first and get all the information it needs to connect to .10. And what's great about that is I could have .10, .11, .12, .13, 14, 15, and I don't have to keep or memorize or have a spreadsheet or whatever of all my connection strings. I just have one file that it knows how, PSQL and all my other programs know how to interact with. Okay? Primary slot name optionally specifies an existing replication slot to be used when connecting to the primary via streaming replication. When we created our slot, our replication slot, we used the name MyBackup. So I'm telling it in the recovery.conf, primary slot name equals MyBackup. Writing the recovery.conf. The next step is to write the recovery.conf file. When using PG-based backup, you can pass -R, right, recovery.conf, in order to automatically write the recovery.conf file. Not all of it, but most of it. And here's my recovery.conf file. Very simple. Standby mode on, primary connection info, primary slot name, my backup, and then I started my secondary. Start the secondary and validate. PGCTL-D main, I should have said data, I apologize. The reason that the error is that I actually tested this on my laptop last night. I run Ubuntu, so the cluster directory is named main, and I basically copied and pasted. So assume main means data. I say start, and then I went into main log, and I tailed the log to make sure everything came up correctly. It says database was shut down in recovery, entering standby mode. Here's the LSN that my redo starts at. I've reached a consistent recovery state, reached at. Database system is ready to accept read-only connections. Don't worry about the invalid record link. That's normal. That's why it says log, not warning or error. Started streaming wall from primary at boom on timeline 1, and I am now connecting to my secondary on .5. I enter in my password, and there it goes. Shows that I'm on an SSL connection using TLS version 1.2 with various ciphers. Compression is off because of that bug in OpenSSL. I do /D to show a list of relations, and there's my little table. Boom. Replication is working. If I were to insert data, I was to create a new table on the primary, of course, it would automatically replicate across. That is literally, I mean, I know it's a lot of information, but it is not complicated. It's step by step how to get replication up and running. Now, we are now successfully replicating. So take a shot, celebrate, walk away. No, there is still more to do. What about that replication slot? We will want to keep the replication slot as it will protect against a secondary becoming out of date in the event of an outage or secondary disconnection. Monitoring replication. Replication is a great tool, but how do we know the state of replication? How do we know everything's working? Right? On the primary, we have a system view called PGStat replication. The values of most interest are in bold. It's useful to know the other stuff, don't get me wrong, but if you just want to make sure it's working, if you look here, my state, I am streaming. I am actively connected. I have a slave or secondary actively connected. I know things are being processed. And then, who is my username that's connected? Postgres. Remember, we do connect as a user to receive the replication changes. Who connected, in this case it was on my laptop, so it's 127.0.0.1. Don't care about the client port. Backend start, that's when the backend for replication started. My state is streaming, but now sent LSN, write LSN, flush LSN, and replay LSN all match. We know we are consistent. And it also tells us the sync state is async. It is not synchronously replicating. So the state, sync state, or did I do that? Sorry. No, the state can be one of the following. Startup. The wall sender is starting up. We're not yet replicating. Catch up. The wall sender connected standby is catching up with the primary. You are most likely only going to see catch up on the initial startup of the secondary when it's trying to get itself into a consistent state with the primary. Streaming, that's what we're doing now. All changes are being streaming. Backup, the wall sender is sending a backup. Or stopping, the wall sender is stopping. We're shutting down. The sent LSN is the last write-ahead log location sent on this connection. The write LSN is the last write-ahead log location written to disk by this standby server. Now, I want to stop there for a second. When we are talking about LSNs, the location, that is something that really only works with streaming. Because archiving is going to ship log at a time. One log, one log, one log. Streaming ships LSNs within the log. So it's more efficient. Flush LSN, last write-ahead log location flushed to disk by standby server. Replay LSN, last write-ahead log location replayed into a database on this standby server. Flush lag, time elapsed between flushing recent wall locally and receiving notification that this standby server has written and flushed it, but not yet applied it. This can be used to gauge the delay that synchronous commit level remote flush incurred while committing if this server was configured as a synchronous standby. It's important because, as we know, synchronous can slow everything down. It's really useful to know how much it's slowing things down. Is there something we can do? Do we need to bond another Ethernet interface? Do we need to change to an internal-only interface? Those types of things. Replay lag, time elapsed between flushing recent wall locally and receiving notification that this standby server has written, flushed, and applied it. This can be used to gauge the delay that synchronous commit level remote apply incurred while committing if this server was configured as a synchronous standby. So we have remote flush and we have remote apply. Apply means the data is actually in the standby. So we can actually determine lag of applying our changes synchronously, whereas remote flush is all about, hey, the data's been shipped, it's on disk, but we haven't done anything with it yet. Sync state. Synchronous state of this standby server. Possible values are async, we know that one. Potential, this standby server is now asynchronous, but can potentially become synchronous if one of the current synchronous ones fails. Remember when we were talking back with the synchronous standby names with the quorum commit, where we could say first, and then say like 3, S1, S2, S3, S4, and then if 2 bounced out, 4 would move up in the chain. That's what we're talking about here. Sync, it is a standby or a synchronous standby, and quorum, the standby server is considered as a candidate for quorum synchronous standbys. On the lag times within PGStat replication, the reported lag times are not predictions of how long it will take for the standby to catch up. Such a system would show similar times while new wall is being generated, but would differ when the sender becomes idle. In particular, when the standby has caught up completely, PGStat replication shows the time taken to write, flush, and replay the most recent reported wall location rather than 0 as some users might expect. This is consistent with the goal of measuring synchronous commit and transaction visibility delays for recent write transactions. To reduce confusion for users expecting a different model of lag, the lag columns revert to null after a short time on a fully replayed idle system. Monitoring systems should choose whether to represent this missing data 0 or continue to display the last known value. Basically, if it's not null, then it's not idle and it's not necessarily up to date. That said, if they all match, you're up to date, but you're not idle. You're still receiving new updates. On the secondary, there is the ability to do a little bit of work on the secondary. You can, in regards to the status of replication. That is, that it knows about. It is kept in the system view PGStat wall receiver. This is actually a pretty big step up because we didn't used to have any information on the standby. It used to be the standby was just a black hole. Now we know whether we're streaming, what LSN we have received, the start of the LSN, what LSN we've actually received, last message send time, last message receipt time, the end of the LSN, slot name, and as well as your complete connection info, but it does hash out the password. So specifically, your PID is the process ID of the wall receiver process. That is the process that's connecting to the primary to receive the data. Activity status of the wall receiver process. Is it streaming? Is it stopped? So on and so forth. First write-ahead log location used when wall receiver is started. First timeline number used when wall receiver is started. Last write-ahead or received LSN is last write-ahead log location. Already received and flushed to disk. The initial value of this field being the first log location used when the wall receiver is started. Received TLI, timeline number of the last write-ahead log location received and flushed to disk. The initial value of this field being the timeline number of the first log location used when wall receiver is started. Last message send time of the last message received from origin wall sender. And last message receipt time of the last message received from the origin wall sender. And almost done. Latest end LSN, last write-ahead log location reported to the origin wall sender. Latest end time of the last write-ahead log location reported to origin wall sender. your slot name, and then your connection info. Okay, so this is where we need to make an executive decision. We can move on to logical replication. But if we move on to logical replication, we likely will not have much, if any, time for questions. So are there questions that we have now that are of consequence, or do we want to move on to logical replication? Okay, yeah. Okay, that's a good question. That would be a logical replication thing. So you cannot binary replicate between, say, 9.6 and 10. You cannot do that with binary replication. However, now with 10 and 11, you can logically replicate between the two, and yes, you could get that upgrade thing you were talking about. All right, I'm going to go ahead and start the slides. All right. So as much as I would love for all of you to show up to my talk tomorrow, you won't need to. The power of Postgres replication, logically speaking. We've already been through all that crap. All right, logical replication. We're going to be talking about what is it, how does it work, configuration, limitations, security, considerations, example architecture, neat tricks, and management. Differences over binary replication. Why is logical replication good, and how does logical replication work? Binary is full cluster only. We would discuss that. There's no partial binary replication. It is an exact physical copy. Binary is streamed or replicated byte by byte. Binary supports other functionalities such as point-in-time recovery. You can't do that with logical replication. Binary can be used for high availability. You can use logical replication for high availability. Don't. It's a bad idea. Why logical replication is good? All good things come to those who wait. The reason that's in there is because we've actually had logical replication for well over a decade. We had Mammoth PostgreSQL for a long time. It does pretty much everything that this does, but it was proprietary. We had Sloaney, we had R server. There was a lot of different ways to do it, but they were all either forks or bolt-ons. We now have built-in native logical replication. It allows publishers to push to a subscriber subset, allows subscribers to be publishers as well. That's key. Think about what I just said. Allows subscribers to be publishers as well. Now, you would think, well, you can do that with binary replication too because you can do cascading replication. That's not what I'm talking about. Okay, this is a different level of flexibility. And it just uses native logical decoding. I don't remember who it was that asked, but asked if you could put a middleware in between the stream. That's basically the logical decoding that you're doing that with. So how does logical replication work? It replays the logical entries in the wall. It has a publisher-subscriber model. It uses replication slots. Subscriptions connect to the slot, meaning parallel streams. It is not SQL replication. This is a common misconception. MySQL has logical replication, but they really should call it SQL replication. And there's problems with SQL replication because when you SQL replicate, especially when you're dealing with, say, constants, so if you say select now, and now returns as this date, if it replicates select now to a slave, Select now and the slave is going to be a different date. So we don't do that. We actually replicate the logical result of whatever the SQL generated. So we don't get those inconsistencies. So let's do a simple configuration. If we're configuring logical replication, on the publisher, the master source or sources of data to be replicated to the subscribers. On the subscriber, the holder of subscriptions which connect to the publishers to receive replicated data. Now, there's a kind of an important distinction here because it can get a little confusing. A publisher has publications. A subscriber has subscriptions. But as previously mentioned, a subscriber can also be a publisher that has publications that another subscriber could have subscriptions to. Okay? Here are the minimum changes to the PostgreSQL.conf that need to be made. Your wall level must be logical. Your replication slots set to at least the number of subscriptions, not subscribers, +5. Why is this really important? You could have a master and a secondary, so a publisher and a subscriber, but within that subscriber, you could have 50 subscriptions or 100 subscriptions, and every single one of them requires a replication slot. So you need to set this accordingly. You kind of need, logical replication takes more planning than binary replication. With binary replication, you're essentially saying, give me a continuous rsync and make sure it can connect and receive updates. I mean, that's what it all boils down to. It's pretty simple. Logical replication, because of how flexible it is a lot more complicated. Your max wall senders, you need to set max wall senders to max replication slots plus number of subscribers. Those are your physical connecting machines. Those are not your subscriptions. Keep in mind other connections that may use max wall senders. Remember that logical replication and binary replication can coexist. So you need to keep into account binary replication or backup software as PG Backrest or PG-based backup. You need to create your replication user. And in this particular case, we want to make sure that we set password encryption to Scram. I said SASL earlier, I meant Scram. Create user, rep user with password, super duper rad password, replication. Yes, you must still have the replication attribute. And yes, you really should switch to Scram. In this case, MD5 would work, but you should switch to Scram. And then you need to configure your PGHBA.conf to allow the subscriber to connect. Here's an example. We've already been through this once. An example, PGHBA.conf. If you look here, I'm saying any host that wants to connect via SSL to the rep test database as the rep user on any network, as long as they connect via Scram, is okay. And I go through this already on the list. Now that we've configured the publisher, we will configure a subscriber. We will then configure a publication and a subsequent subscription for replication. Okay, so this is for the subscriber. Modifications to the PostgreSQL.conf. Max replication slots equals the number of subscribers plus some. Max logical replication workers equals at least the number of subscriptions, not subscribers. Remember, a single subscriber could have 50 subscriptions. +5 for synchronization. That's important because it is possible to send multiple streams to sync your subscriptions. It can actually be faster than binary replication for syncing the database if you are replicating the full data set. because it will sync or flush, what do you want to call it, multiple tables, multiple subscriptions at a time. But and then max workers, I think that's actually supposed to be max worker processes, equals max logical replication workers plus one, perhaps more. Now remember when we were talking for binary replication, for max worker processes, we had to combine all of those values and then like add some, either ×2 or +5 or whatever. This is where this is coming into play. Because if you just set max worker processes to max logical replication workers plus one, you may not have enough. Notes, remember when setting these values that a subscriber can also be a publisher. If your subscriber is also a publisher, you need to make the previously discussed changes to the PostgreSQL.conf and PGHBA.conf for the publisher as well. Publications exist on a publisher. Subscribers can also be publishers. You may have any number of publications. It is a one publication to end subscriptions model. Okay? So when I say I have a publication of table foo, I can have 50 different servers with 50 different, or each one with their own subscription to that single publication of foo. I don't have to create 50 different publications for 50 different subscriptions. They may contain a single table, mini table, or all tables. Creating our publication. Create publication, my pub, for table users, departments. Very simple. I now have a publication. I've got a database full of 1,000 tables. I now have a publication that says I only want to publish users and departments. That could be very useful if you were, for example, replicating specific human resources data to a subscription, but you didn't want to replicate everything else. In this syntax, my pub is the name of my publication. For table users department is the tables to be included in the my pub publication. You may also use for all tables instead of for table without a list of tables, which will create a publication for all tables, including tables created in the future. That's actually a pretty nice feature. What it's saying is, if I want to create a publication that's the whole database, I don't have to list out every table. Whole database right there, my pub. But I don't want to have to alter that publication every time I add or drop a table. So if I add or drop a table, the publication will automatically update. Advanced publication features. You can limit the type of DML allowed, the data modification language, for a publication. For example, create publication, my new pub, for table, table 1, table 2, with publish equal insert delete. What does that mean? It means that updates will not be replicated. Only inserts and deletes. Now, insert delete's kind of a weird one, but insert has a lot of use. If you think about a logging table, an audit table, all you want is anytime you add new data, you want that to also be translated or transferred. You don't care about updates or deletes. The publish option allows you to specify which type of DML results will be replicated. On the subscriber, create subscription my sub connection $, and then there's my con info. So DB name rep test host equals bar, user rep user, publication my pub. Now, look at the dollar quoting. Anybody here ever use dollar quoting? One or two people? Okay, here's the great thing about dollar quoting. Who here has ever tried to escape a backslash? Okay, escaping a backslash. It's a nightmare. It's backslash, backslash. I think it's 4 of them, isn't it? It's like backslash, 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 backslash to escape one backslash. Well, dollar quoting figures it all out. If you got a backtick, you got any character that needs to be escaped, it just knows how to deal with it. So you don't even have to worry about it anymore. You just use dollar quoting in all your stuff. This also works if you're writing functions in like PGSQL or whatever. It also works in your DML statements. So if you want to protect against SQL injection, you want to make sure no weird escaping happens, you can use $$ instead of quote. And it just figures everything out for you. It's magic. Now, it's not portable by any stretch of the imagination, so it is definitely Postgres voodoo, but it is beautiful Postgres voodoo. This will create a subscription and begins the synchronization process. Once synchronization is complete, incremental changes will be replicated. You need to be careful with large tables. The synchronization process is just a copy, aka long-running transaction. Long-running transaction bad because routine maintenance such as auto vacuum will not work during the transfer. Okay? So if you've got a 500 gig table that you're about to ship, think real hard about that. Logical replications limitations. DDL commands are not replicated. Alter table, create table. Use pgdump schema only. This is a little bit frustrating, and to me, it's a artificial limitation. We know how to do it because there's an extension called pglogical that bolts on top of this that does it. We just didn't implement it for some reason. I don't know why. I mean, it might have been a time thing. But so you can use something like pgdump schema only to move your DDL across. Sequences, serial, big serial, and identity are not replicated. Number one, not the most important reason you can't use it for high availability, but the number one reason in this talk why you can't use it for high availability is that if, like most people, regardless of right or wrong, your primary keys are a sequence of some sort, and you replicate all this data, and you go to fail over, you're going to have a billion rows with a sequence value of 1, which means you will instantly get errors when you start to modify that data. So if you were going to fail over, you'd have to have this elaborate scheme of checking every sequence against the column that's associated with, grabbing the max value of that column, adding +1, and setting curval on every sequence, and then coming up. It would be ridiculous. There's just no reason for it. Truncate is not replicated. When I found this out, I was actually irritated at first, and then I thought about it, and it really shouldn't be, because if you truncate on the primary and it moves down to the logical secondary, the problem is the table that the logical secondary is getting replicated to might have multiple sources of data. So you'd have this situation where you actually have 5 sources of data in one table, but one master, one publisher, hit truncate and then deleted that 5 sources of data. So truncate is a no-no. Large objects are not replicated. Most people don't use large objects. Anybody here using PG large object? Yeah, I didn't think so. I actually like PG. It's non-standard. I like PG large object because it's much more efficient than byte. The nice thing about PG large object is that if you put like a 90 meg PDF into it and then you go to retrieve it, it literally streams you the PDF in 8K chunks. Whereas a byte, if you put a 90 meg PDF in there and you pull it out, it sucks down the whole 90 megs all at once and doesn't release the resources. But it is non-standard and most people don't use it anymore. Here's some continued limitations. You can only replicate tables. No views, no map views, no foreign tables. There you go. Another reason you can't use it for high availability. Well, not the foreign tables, but the other two. You cannot create a publication that is a foreign table, a foreign data wrapper. Instead, you create the publication that is the source of the foreign data wrapper. So if you need the data from the foreign data wrapper, you just need to make sure, well, more specifically, it's going to have to be Postgres, but you need to, instead of other foreign data wrappers, but you need to make sure that you create a publication on where the source of that is to pull that data down. You have to replicate child partitions, not the parent. So you can't just create a publication that says replicate foo if it's a partition data set. It won't even work. You have to replicate the underlying tables. It is best to have a primary key. You don't have to. You can say something like alter table rep test replica identity full. But if you do that, what it essentially does is every single row that gets replicated creates a where clause of where column equals column, column equals column, column equals column, all the way across to get a unique row. So if you got a 50-column row or table, it's hugely inefficient. Just do the right thing and have a primary key like you're supposed to. I mean, you're supposed to have a primary key anyway, so just do that. Limitations, conflicts. This is the big one why high availability just does not work with logical replication. Remember that a subscriber is writable. It's not a read-only device, unlike binary replication. If you change data on a subscriber table, the data between the publication and the subscription may differ. Further, conflicts break replication. So unlike binary replication where you really can't do anything to break a slave, at least from Postgres, I mean, you can break it underneath from the OS, but in Postgres you can't really break a slave. The problem with logical replication is there is no slave. There's no read-only. You are a subscriber to a publisher. And specifically, you have a subscription to a publication, which means that your subscription is writable. You could have multiple instances of things coming into that table, multiple subscriptions into that table from multiple publications. Also, you could, if you wanted to, for whatever reason, just say update foo set bar to 1. And then all that data updates, and the publishers don't know or care. So you can break your app. But worse, and that's actually by design because you get a lot of features that way. There's a lot of things you can do. But the problem is, let's say you update everything on the subscriber. Everything's fine, but then your publication sends over a row that violates a foreign key because of the changes you made. Replication stops. Stops cold. It is now broken. You have to fix the error and then resynchronize. It's just, which is not what we want with high availability. What we want with high availability is I fail over, it works, everything's good. That's what we want. The following will not work. This I actually asked about this when I was writing this content. It is not a limitation of the features or the logical replication. It is a limitation of time. They just didn't get around to it. This would be very useful to me on a publisher. When I say public.foo, I am talking about schema public table foo replicates to the subscriber schema private.foo. That would be, think about a situation where you've designed an application where every single client has their own schema and their own set of data within that schema. Instead of a bunch of databases, we got a bunch of schemas. Well, it may be nice to say, here are my EMEA clients. Here are my US clients. But I only want that for my central data store where I'm doing reporting. Also, publisher public.foo replicates to subscriber partitioned public.foo. That does not work either. That is even more useful if you think about a scenario where you have a bunch of edge servers that are processing transactions that are maybe sending down audit logs or something like that to a central store. And then you want to be able to partition that data set. Further, as I mentioned, the replication doesn't work quite right with partition tables, but there is a way around it. Special care must be used. And this is how you do it. In order to replicate partition tables, you must create a publication which contains each base table within the partition set you wish to replicate. For example, we create our table part test, very simple, ID big int test text. Primary keys don't work on partition tables. That is no longer true. As of 11, primary keys work on partition tables, just not as of 10, which is what this was written on. We create table part test 0, partition of part test for values from 1 to 100. We create table part test 1, partition of part test for values 101 to 200. Then I can create a publication part test for tables part test 0 and 1. Notice I'm not replicating the parent table because the parent table is essentially an envelope. It doesn't actually exist. Everything is getting put into the buckets below it. Security. The role used for replication connection must have the replication attribute, showed that earlier. To create a publication, the user must have the create privilege in the database. To add tables to a publication, the user must have ownership rights on the table. To create a publication that publishes all tables automatically, you must be a super user. To create a subscription, the user must be a super user. Now you would think, why is that the case? Well, you don't want any arbitrary user to be able to connect to any arbitrary publication and start pulling data. So if you are creating a subscription, you must be a known, admin rights user. To create a subscription, the user must be a super user. I did that one. The subscription apply process will run in the local databases or database with the privilege of super user. That's important because the objects don't need to be owned by a super user. But when you pull that subscription down, it is going to be a super user. So it's kind of like a loophole for security to make it work. Some considerations. Each sync is an internal copy and snapshot. That was to beware of long-running syncs because it's a long-running transaction and it will affect auto vacuum and it will cause bloat, period. You need to prepare for that and manage for that. Each replication slot is a separate connection, thus parallel streams, which in turn can cause a copy. That could be a potential performance hit, long-running transactions, and or cause bloat due to limitations with vacuum, auto vacuum. Also, remember max connections. Okay? I think I showed you this before. This is an example architecture where we've got our human resources app plus full subscriber to SalesDB. Then we have public-facing SalesDB, read-write SalesDB. It's using logical replication to create a single canonical database of full subscriber plus the HRDB, which uses binary replication for a hot standby. And then over here, we have a DR hot standby of the SalesDB. So we are integrating both. I have a second one, I believe. Yeah, here's the second example architecture. This is actually one of my favorites. This is from a potential client that they have a set of data that must be published to a particular location and then they have another location that has a set of data that needs to be published to the original location. But here's the catch. They can't touch each other. Okay? So what we have is USA primary, table group A. So we've got a group of tables that will replicate to the Asian primary so that they have access to that data. But they have a table group B, which is a completely separate group of tables. It's not ABC, they're DEF. They have to replicate back to the USA. And then, of course, we do have an async binary replication for the Asian primary and then a synchronous binary replication for the US. This is a great example of where logical replication can be useful. Because you have a scenario where Asian, or it doesn't matter which one you pick, but the Asian primary is not allowed to, for regulatory reasons, connect and use this application. And the US primary is not to, for regulatory reasons, able to connect to the Asian primary. But there is specific data that they have to exchange for their services to work. And we're able to do that with logical replication. We would not be able to do that with binary replication because it would violate the rules, the business rules. Some neat tricks. This works. I believe someone asked me about this earlier. Create table foo, bar text, baz integer, replicates to subscriber, create table foo, bar baz employees. That'll work. The other way won't. You cannot invert that. But you can do it this way, which would be great because then you can have a situation where table foo, I mean, I don't know why I picked employees, but you would update employees on table foo on the subscriber based on, bar or baz. And it has nothing to do with what the publisher is doing. The publisher only needs to have the data that it needs. It is just native logical decoding. It's just integrated now. So we can replicate to Kafka, to MySQL. Like I said, don't do this, but there it is. Mongo, PG Logical, which is an extension that has added benefits like schema replication instead of having to use like PG dump all schema, as well as some conflict resolution. All right, a little bit of management. How we manage the publications and how we manage the subscriptions. We can alter a publication. So it's not like the publication is static. We can add a table or all tables using star. We can set a table only to a table name. We can drop a table. We can set a publication parameter. Remember when we were talking about changing whether or not you did insert and delete only for the DML? You can change the owner of a publication, and you can rename a publication to a new name. Subscription gives you a little bit more. You can alter the subscription, the name of it, how it connects, what the publication name it connects to. You can refresh from the publication. You can enable it, disable it. You can set specific values. You can change the owner, and you can rename it to a new name. You can monitor it with PGStat subscription. I didn't do an output of this, but so you've got your subscription ID, which is the OID of the subscription. You've got your subscription name, the process ID of the subscription worker, the relation, the OID of the relation that the worker is synchronizing. This is interesting because what you would be able to do is actually map that in PG class and know if you have a subscription that has multiple tables, you'd be able to know exactly which table is currently being worked on. Received LSN is last write-ahead location, last message sent time, as well as receipt time. We've talked about that before. As well as the latest end LSN, last write-ahead log location, reported to the origin wall sender, and then the latest end time, the last write-ahead log location, reported to the origin wall sender. And that's it. I mean, we've got some time. We've got 10, 15 minutes if you guys want to take questions. If not, that's cool too. Yeah.
Hi, thank you.
Oh,
One. Oh. I will talk in English, it's okay.
Oh, you speak English?
Yeah.
All right, go ahead.
So I would like to know if we replicating information to Kafka, what format will it be? Is it pure SQL or how?
It depends on how you do it. If you are using the logical stream decoder for Kafka, it is going to be in the standard Kafka format. I don't even actually know what that format is, but I know it'll be native to however you send it to Kafka. And you can modify that because it's just a queue, right? So however it is that it accepts the queue natively would be how you would do it.
Is it possible to track all the changes, like inserts, in the same format as it was? You said that it is logical result, not the queries itself replicating. So may we have a queries itself, like inserts, to provide them next to the next sources through Kafka?
So you want to audit all changes and you want those changes shipped into Kafka?
Yes.
Yeah, absolutely, because now it'd be a little tricky because you can't, there's no native auditing to Postgres. So what you could do is install the extension like PG Audit, and then you would create a publication of the PG Audit tables, and then you could create, through the logical decoding, you could subscribe to that publication and then ship it into Kafka.
Oh, I got it. Thank you very much. It's
You're
very
welcome.
useful. Thank you.
Anybody else? Oh, over there. Oh, while I'm just curious, I have no idea if that's accurate. Google told me it was. Thank you. Okay, good.
It's correct translation. Thank you for your time. I have a question. Please tell your vision about situation known as split brain. Maybe with some solutions examples.
Split brain?
Yes.
Okay, so for those that don't know, split brain is when you end up in an environment where you had a primary and a secondary. The secondary promotes, and now you have a primary and a primary. And how do you deal with that? It's a little tricky. So in Linux, the best way to handle it, and it's also the most complicated way to handle it, is you got to use what's called fencing. And when fencing, what happens is that when the HA cluster determines that it needs to fail over, it won't allow a split brain scenario because it literally cuts off the former master and the secondary comes up. But in order to do that, you have to use the Linux HA tools, and they are anything but simple. Okay? The other option that you can do is use a single floating IP. And this is the most useful option in that, or simplest option, because what happens is, in the event of a secondary promoting, even though the master is still valid, everybody's connecting to the floating IP. So that floating IP is going to ship to the secondary, and although you technically have a split brain at that point, you don't, because all your applications are only going to connect through that single source. So yeah, you would have to, you're on the single source and the secondary has been promoted, and then you would have to demote the primary and then turn it into a secondary, but you don't have a situation where applications are trying to figure out where to connect and data is being updated in different places. The biggest point, where I run into split brain the most is if people are trying to use DRBD for HA. If you don't know what DRBD is, I don't remember what the acronym stands for, but it's block level replication of your disks, of your volumes. And it is known that if you're not careful, that you can get a split brain where you literally have two Linux operating systems with replicated file systems that think that they're in charge. But if you're not doing that, avoiding split brain, it's not impossible, but it's not that hard either, especially with the floating IP.
Okay, thank you very much.
Okay. Anybody else?
Спасибо. У меня вопрос про бинарную репликацию. Я правильно поняла, что ее можно настроить, не настраивая слоты репликации? Вот. Если это так, то в чем риски? То есть зачем настраивать слоты?
Yeah, you absolutely can set it up without the replication slot. You could either use archiving, which would ship the logs in case of disconnection. The biggest risk of not using the replication slot is that you will, if you're not archiving at the same time and the secondary disconnects, you could have a situation where you overrun essentially your max wall size, and then when the secondary reconnects, it'll be out of date. It won't catch up. So you can't safely do it without either A, a replication slot, or B, archiving. If your situation is that your secondary can't talk to your primary, which is often common, use archiving. That way the primary can ship the logs to the secondary so it's always up to date should it get disconnected. Does that make sense?
Спасибо.
Next.
QR code for the last presentation?
Oh, we don't actually have one for the last presentation. Okay. So the QR code, I do not actually have a QR code for these slides, but I will make sure that the organizers get a copy of them to post up. These are free slides, so I'll make sure they get up. Do you put your slides on the site? Do you know on the PGConf site? Anybody?
Not sure.
I'll make sure the organizers get them. You can request them. It won't be a problem. All right, any other questions? All right, thank you very much. You guys have a great evening.